Hello, so in today's video, we're going to answer question 7 from the 2022 Paper 1 Edexcel A-Level Maths exam. So this was, we've done a few questions of this paper before in some of my previous videos. So we've done question 1, question 2, question 3, 4, 5, and 6. So again, this is 2022 Paper 1 Pure Maths from the Edexcel syllabus. And even if you're an AQA student or an OCR student, it's still the A-level syllabuses are pretty much identical across the board. So this is still relevant for you to go through an example past paper question. So let's do this question 7 then, which is a proof question. So question 7, so we've got given that P and Q are integers such that P times Q is even, use algebra to prove by contradiction that at least one of P or Q is even. Okay, so with this one here, we want to prove by contradiction that at least one of these numbers is even. So remember, with proof by contradiction, if you want to prove something by contradiction, you have to assume that the opposite statement of your conclusion is true. So the opposite, or the negation, is really the technical word you should say, but the opposite statement of saying at least one number is even would be saying that both numbers are not even. So the opposite statement to this, the negation of this statement would be that both of these numbers are odd. So we want to prove that at least one of them, so either one or two of them, are even. So the opposite to that would be both of them are odd. So assume to the contrary. So we're going to start our contradiction proof by assume to the contrary. So assuming to the contrary that P and Q are both not even, so both odd integers. So they're both odd integers. So what is the consequence, or what are the consequences of having two odd integers? So that means that you can say that P is equal to 2n plus 1, where n is some other random integer. And you can also say that Q is equal to 2m plus 1, again, where m is just some other random integer. So we've got two odd numbers, P and Q. And so what we're going to do now is times them together. So we know there because we've got to assume this. So the question requires us to assume that P and Q are both even. So, I mean, we're assuming that. So P times Q must be even. So you've got this even number. So you've got this even number, P times Q. So P times Q is even. Now let's plug these results in. Let's plug this 2n plus 1 and this 2m plus 1 into this to see what we get. So 2n plus 1, and then times by 2m plus 1. So we've got this even number. We're going to times the brackets together, so expanding our brackets. We get 4nm there. We get 2n there. We get 2m there. And then we get plus 1 from there. So we can actually just factorize out of 2 from the first 3 terms. So we get 2 times by 2nm plus n plus m, and then plus 1 at the end. So what can we conclude from this? We got 2 times this whole number here. So obviously n and m are whole numbers. So these are all whole numbers in here. So we've got a whole number times by 2. Well, this must be an even number, obviously, because any whole number times by 2 is in the 2 times table. So it's an even number. And then we're going to add 1 to it. So again, even number plus 1. Pick any even number and then add 1 to it. You get an odd number. So that's a problem because we assumed at the start they were even. So again, remember the question told us that P and Q are two numbers such that P times Q is even, but the maths here has just shown us that that even number is odd, which is a contradiction. So this is a contradiction because an even number can't be odd. So that's a contradiction. So therefore, P, at least one of P or Q, shove this out here. So at least one of P and Q must be even. So I'll just write it here, must be even. Okay, so that's the first part of the question done. We've done part I. Now, how about part 2? So given that x and y are integers such that x is less than 0 and x plus y squared is less than 9x squared plus y squared, we've got to show that y is greater than 4x. So we're given these two pieces of information here. Part 2. So we're given that x is less than 0, and we're also given the next piece of information that x plus y squared, so x plus y all squared is less than, sorry, let me rub this out, so less than 9x squared. And then what was the next bit? It was plus y squared. Okay, so we know that as well. So what we're going to do, I think the way that I'll do this is just use this second piece of information there and expand the brackets, and let's just see what we get. So from the second piece of information, expanding our brackets, so x plus y times x plus y, it's got to be less than 9x squared plus y squared. So expanding our brackets on the left-hand side, we get x squared plus xy plus another xy there. So you're going to get actually 2xy there. And then y squared there plus a y squared. It's got to be less than 9x squared plus y squared. Now we've got y squared, a plus y squared there, a plus y squared there. If we take away y squared from both sides of the inequality, that will just disappear. So what we're left with now is x squared plus 2xy is less than 9x squared. And in fact, what we can do now is actually just take away an x squared from both sides. So we get 2xy is less than 8x squared. And in fact, we can just half the two coefficients there, the 2 and the 8. If we do that, we get xy is less than 4x squared. Okay, so we have this. Now we know that x is a negative number, so x must be a negative number. And we know that x times y must be less than 4x squared. So we got this negative number x. So what we're going to do now is we're going to divide both sides. So again, if we just go back to the question, we're trying to show that y is bigger than 4x. So what we want to do is we want to divide both sides by x to get y to be subject of the inequality, essentially. So divide both sides by x, but remember x is a negative number, so x is negative because the question told us that x must be less than 0. So we've got this negative number x. We're going to divide both sides by it. So remember, when we divide a negative number through on an inequality, we must change the sign. So the sign must flip now. So let's just make a note here. Sign now flips over when we divide by a negative number. So that means we're going to get from here, so we get, sorry, this is a really bad arrow. So we get from here y, and now that's got to be bigger than 4x squared over x. And so therefore the x's cancel out. And so therefore y is greater than 4x. And that is the conclusion that we needed to obtain in the question. And again, that's because when we divide by a negative number in an inequality, you have to flip, you have to change the direction of the sign, because you're flipping the number line over because you're dividing by a negative number. So that means your sign has to change accordingly. So that would be that question. So this is question 7 on the Edexcel 2022 paper, paper 1. This is pure. So just using proof by contradiction and then doing some algebra, some inequality work to prove a certain result. So yeah, I'll see you all very soon.